So thanks for coming to listen today. I'm going to present results from our 2011 project, looking at how grizzly bears respond to oil and gas development in Alberta. So of course this project was funded by the Alberta Upstream Petroleum Research Fund, and we had a number of other program partners in 2011. And this was research that we completed at Foothills Research Institute along with our colleagues at UVic. I see that changing versions of PowerPoint is going to be a problem here, so apologies for that. So hopefully all research has a reason behind it. The main rationale for this research was that there was a knowledge gap. So there's been a lot of research done on grizzly bears in Alberta and elsewhere, including looking at effects of industrial development, but most of this research has focused on forestry impacts and roads. So there has been some early research done on the effects of oil and gas exploration, things like seismic exploration, human-bear conflicts at work camps, that kind of thing. But really, as far as we could find, there weren't any published data looking at how bears are responding to ongoing oil and gas operations on the ground. At the same time, oil and gas development is on the rise in Alberta. And in 2010, the grizzly bear population in Alberta was classified as threatened, so it is now a threatened species in our province. So how bears respond to oil and gas is a rather large research topic. We tried to focus it down a little bit, and when you're talking about industrial development and wildlife, something that you often want to know is habitat. How is habitat use affected? So is grizzly bear use of habitat affected by the presence of these oil and gas features on the landscape? And we wanted to look at that at a large scale, sort of landscape scale habitat use, and also at the finer scale of the actual features, so at the level of the well site, what was going on. And then knowing that industrial development often can affect risk of bears dying, in other areas of the province, the more, as you probably heard, the more roads, the more development, the higher the risk. We wanted to specifically look at mortality risk in our study area in west central Alberta. So here's our study area. It's right in between Grand Cache and Grand Prairie. Is that too loud? Oh, okay. So just north of Grand Cache, just south of Grand Prairie, centered around the Kakwa River. About 8,300 square kilometers makes up our study area. It's outlined in green here, and we have a field camp almost in the middle there. You can see it's an area with a lot of development. I hope you can see. Lots of cut blocks, roads, well sites, and pipelines in this region. So we've been working in this area for quite a while now, so we have quite a lot of GPS collar data over the course of about 6 years. We're still working in this area today, but for this study we used data from 2005 to 2010 on about 30 some grizzly bears, adult males, adult females, and sub-adults. So to do the analysis, of course, we needed oil and gas data. We got those from Alberta Energy, Wellsite and pipeline data, which are provided to Alberta Energy by operators, probably some people in this room. And based on the information that Alberta Energy provided to us in that data set, we could classify our well sites. So we wanted to classify them if they were actively pumping or if they were discontinued or abandoned. We wanted to separate those two kinds of features. So we did that using spud dates, on production dates, lost production dates, that kind of thing. And our roads data we got from, hopefully I say this right, Alberta Environment and Sustainable Resource Development, AESRD. And those data are updated by ASAT, Foothills Research. And just something I wanted to point out, roads in this area are a result of forestry development and oil and gas development. So it's not possible for us to separate those out in our analysis. So just something to keep in mind when we're talking about the impacts of roads. So our first objective was to look at this large-scale habitat use. So if you take this habitat and you add in all these features, what are bears doing in response to those features? Are they closer to those features than you would expect? Are they farther away? So in other words, are they avoiding them? Are they close to them? Do they not care? How are they using the landscape in and around these features? And we wanted to look at that seasonally, knowing that bears choose different foods, different bear foods are available at different times of year. We wanted to look at how the habitat use might differ depending on those seasons. And we separated out the response to these 4 different features. So our active well sites, our inactive or abandoned well sites, or discontinued well sites, pipelines, and the roads. And then we also wanted to look at differences between different groups, so males, females, adults, subadults, and we wanted to investigate if there might be any differences by time of day, knowing that there's a higher level of human activity on that landscape during the day. Would that affect how bears use their habitat around these features? So to do this, we generated what our expected use of the habitat. You always have to compare actual to expected when you're doing habitat use, and we generated our expected based on habitat quality. So in other words, we expect bears to be in areas of higher habitat quality. And then we took the distances from the actual locations, the observed grizzly bear collar points, and compared those to the expected, and each set of data points were classified as closer than expected, further, or no different, or in other words, no statistically significant difference. So I'll just back up here for a second, so you can imagine when you take 3 different seasons and 4 different classes of bears and 4 different oil and gas features, we ended up with really a lot of results. So I'm really generalizing here on our results. I'm just going to provide you with the kind of the main findings of the results that stand out. So in the spring, most of our bears were either closer than we expected or no different from all of our oil and gas features. So another way of looking at this is that we didn't really see any avoidance of these features in the spring. And our adult males tended to be closer to these features at night compared to during the day, so there were some day-night differences here. In the summer, this kind of switches. We found our adult males were farther than all of these features than we would have expected, or most of them were anyways. And then again, we saw some day-night differences. This time, all of our classes of bears, so adult males and females, sub-adult males and females, were all closer at night compared to daytime. And then in the fall, our sub-adults were farther than we would have thought from active well sites. A lot of our bears were closer than we would have thought to roads. This was a bit of a surprising result for us. Excuse me. And females were closer at night compared to during the day. So just to sort of summarize some of these results, that we saw a bit of a pattern. Closer or not different than you would expect in spring. Spring is a time of the lowest amount of drilling operations in our study area. During spring thaw, there's a lot less activity on that landscape. You would assume during the day there would be more activity than at night. And bears were farther during the day compared to at night. And there was this avoidance of active well sites in the fall. Fall is a time when there tend to be more people out on the landscape hunting, that kind of thing, although it was a bit surprising to us that bears were closer to roads. So these 3 results kind of suggest that maybe there's some kind of response to the level of human activity on that landscape going on, so this is helpful. But in terms of sort of looking at general large-scale patterns across all of the bear classes to all of the features, we didn't quite get the conclusive, clear-cut results that researchers are hoping for. There was no really distinct pattern across all classes. So we got some information here, but some bears were closer, some were further, it depended on the season, that kind of thing. So this made us wonder, if bears are closer, sometimes further, we started to think about what's actually going on at those features. So this led us to our second research objective, which was looking at a finer scale habitat use. So what's going on at the level of the well site? Are bears showing avoidance of those well sites at that small scale, or are they using those well sites? And this was based on some work that a master's student from Sweden had started a few years ago, looking at selection of well sites, and also based on some anecdotal evidence of bears visiting well sites. So we did this by creating some buffers. I'm not sure if that picture is big enough for you guys to see, but around each well site, we created a 100-meter buffer, and that included the cleared well pad plus the forest edge. included that area pretty well. So when we're talking about the 100-meter buffer, it's pretty much right on the well pad or right in the edge. And then we also wanted to look at a potential zone of influence. So other researchers have shown with other species, and also this has been looked into with bears, sometimes there's this zone of influence. So someone talked about it earlier with the caribou stuff, they apply a 500-meter buffer to human features. So the idea is that the effects of that feature extend past the feature itself. And we wanted to look into whether or not this zone of influence applied with bears and well sites. So we used a fairly simple analysis method looking at selection ratios. So basically you're looking at the proportion of area that's made up by these different habitat types and the number of points in these different zones, and you're concluding if it's there's use is more than you would have expected. So for these three zones, this well site zone, this potential zone of influence, and the rest of the home range. So the yellow circles are that 100-meter buffer, and the red circles are that 500-meter buffer. So a little bit surprised by our results. Out of the 16 bears that ended up in this part of the study, 10 of them actually had selection ratios greater than 1. In other words, they were spending more time on well pads than we would have expected based on the proportion of their home range that was made up of those well pads. So just a little summary of results for both of those zones. Similarly, in that 500-meter zone, the majority of our bears spent more time there than we would have expected. 3 of them spent less time, and 4, there was no difference. So again, these results are pretty variable, but this made us really wonder, why are bears going to well sites? And we didn't have enough time or resources to do a full field study or analysis going to well sites to check out what was growing there, but we did visit about 20 well sites. So I'll just present to you a little case study that I wanted to look at one of our well sites. These results really got me wondering. I was concerned that maybe some of the bears were skewing the results by potentially there was a kill site at a well, or for some reason some bears were spending tons of time at certain wells and this was skewing the results. So I just set about looking at some of them, and I don't know if it shows up very well for you, but so this particular well site, which randomly we called wellpad number 29, there's points from 4 different bears across 4 different years, and these points included bears would return more than once across the seasons. So they weren't just going there and staying there for several days at a time. They were coming back repeatedly to these same well sites. So we wanted to check out what was going on there. So we found that there was a lot of clover growing there. This probably is not a big surprise, but high cover of clover, and in the forest edges, a lot of berry bushes. So at this particular one, a pretty high abundance of huckleberry bushes, and in 2011, tons and tons of berries. These aren't even huckleberries in this picture, I admit. This was just a shameless way of putting my daughter in the presentation. So bottom line is, bear foods are available at well sites. Again, this is something that probably a lot of you already knew, but hadn't really been documented, at least as far as we could find. So clover, Equisetum, and dandelion, or horsetails, Equisetum, were really abundant at these sites, and the only time they were absent was if a well site had been cleared within the last year or two. And then again, the berry shrubs were abundant in these forest edges. So I just want to show you a little animation, or sort of a recreation of one of our bears moving through this landscape. So this is our study area in black, and the home range of one of our bears in blue, G260. G260 has been working for us for a number of years. She's been faithfully collecting data for a few years now, and I'll just zoom in a little bit there. So you can see this was her home range in spring of 2012, this year, and you can see it's a fairly altered landscape that she lives in. So we'll hope that this animation works. And it looks like it will. So G260 is the red circle, And as she's moving through the landscape, you can see the time scale on the bottom right there. Every time she's within 100 meters of a well site, it does that exploding circle thing. She's leaving a trail of where she's been behind with those green points. This is an effect that our GIS guy was really excited about. The more time she spends at the well site, the more the circle explodes. So just to give you an idea of how she's using that landscape, she was one of our bears that showed selection for well sites, and you can see that she's visiting them a lot. We don't know exactly what she's doing at those well sites. We can only assume she's taking advantage of those foods. So this video runs from mid-June of this year till the end of July. I'll just let it run for a few more seconds here. But the well sites that she's already visited stay lit up in white here, and the ones that she hasn't visited are kind of a darker gray. So you can also see that she's going back to some of the same ones. She's hitting them kind of over and over. So not all on the same day or at the same time. She's going to a well site, leaving and coming back. So just kind of go back over some of our main findings with our large-scale habitat use and our small-scale habitat use. Large-scale, one of our general patterns was not a lot of avoidance in spring, neutral or closer, and in the fall, some bears were farther from active well sites, closer to roads. At the level of the well site, most of our bears actually showed selection of those well pads, and some showed selection for that zone of influence, so not a lot of avoidance of that zone of influence, so we don't think there's a really strong case for this zone of influence or zone of avoidance existing for bears and well sites in our study. So again, unfortunately, not the 100% clear-cut kind of results that you might want with research, so there's some selection and some avoidance. So we tried to think of what does this mean for us? What are the implications of this? So what are the implications of the fact that sometimes bears are at or close to oil and gas features? What are the implications for the bears, I should say? The implications for the equipment here are obvious. So anytime bears are near human features, there's an increased potential for human-bear encounters, obviously. This could mean a risk to oil and gas workers. Imagine being the person who's supposed to come and service this well on that day. And anytime there's an increased potential for human-bear encounters, we know from information from other studies in other areas that this increases the chance of bears dying. So whether it's from hunters using these roads to access and maybe shooting a bear in self-defense or poaching or any of those kinds of causes, we know from other research that when you increase the chance of humans and bears encountering each other, it often doesn't end well. So this led us to our third research objective, which was looking at mortality risk for our area. So we've been looking at mortality risk across the Grizzly Bear Range for a while, but we wanted to know what was the risk for our specific study area, the Kakwa study area. And how is this risk changing? Was it staying the same from year to year? Was it going up? Was it going down? What was going on in that region? So we used mortality risk models that the Grizzly Bear program has been running for a number of years, and these models are based on 9 parameters: distance to road, distance to forest edge, distance to stream. Basically, they're based on visibility and accessibility of bears. So if people can see bears and people can get close to bears, their risk of human-caused mortality goes up. But we had the advantage this time of using our updated oil and gas data sets that we had created for the rest of our project to feed into these models. So these models are included in our deliverables to our program partners each year, but for this study we used this upgraded data set that we had created. And we also wanted to know these models were created elsewhere. Do these models apply to our area? So we took the risk surface and we plotted the known mortalities on this risk surface to see if this model is working in the Kakwa area. So mortality risk is at relative scale. It goes from 0 to 10. 0 is the blue here and 10 is the red. And so 0 means low and 10 means high. It doesn't mean a percentage of bears that died or likelihood. It's just a relative risk scale. So you can see that most of our human-caused mortalities do land in the red zone. We have a few down on the bottom here that are sort of in the blue zone, but when you take a closer look at these in GIS, when you zoom in, they're in little sort of islands of red in that blue zone. So this was good. Our model was predicting mortality risk well for this area. So looking at annual mortality risk in the Kakwa study area, you can see there's a big jump between 2004 and 2006, and then it kind of levels off a little bit, sort of steady incline. So predicted mortality risk in this area, we would call it moderate, for lack of a better word. Again, the scale is from 0 to 10. And the biggest increase was between 2004 and 2006, and that's also when the most well sites, pipelines, and roads were added to the landscape during our study period. So this is probably, maybe seems kind of obvious, but this was just something that we hadn't specifically looked at before for our area. So we really didn't know what was going on with risk, but risk is steadily increasing in our area as development increases. That's common sense. This means there's a potential for an increase in human-caused grizzly bear mortalities. You assume if your model is working well, and it looks like it is, increased risk means the potential for grizzly bears actually being killed. So, of course, we think this has important implications for conservation and recovery. So just kind of some general conclusions. We got some good preliminary information on here, but there isn't as simple of a pattern as we would have liked in terms of displacement or use of these features. So this maybe doesn't seem like a very conclusive conclusion, but sometimes bears are at or really close to oil and gas features. What does this mean? Higher risk of mortality and potentially implications for safety for oil and gas workers, we think. And this is important to consider as we're trying to recover the species at the same time that oil and gas development continues in the Kakwa area. So, future directions, we're definitely starting to fill that knowledge gap, and we're working on publishing some papers on this work right now. But when you're a researcher, you always recommend further research, right? That's how we all stay employed. So we'd like to do further work on what's going on at the level of the features and focusing on pipelines, and also on movement patterns. So we've looked at habitat use and how that's affected, but how are movement patterns affected? We did some preliminary work on this, and we want to expand on this. So in 2012, we were lucky enough to get some more funding from Alberta Upstream, and we visited about 300 study sites on pipelines, looking at what bears were doing there and what was growing there. Kind of our basic research questions were, do bears use right-of-ways? Are they on right-of-ways? And then sort of anecdotally knowing that they sometimes were, if they're there, what are they doing there? Are they using their pipeline right-of-ways for movement? Are they foraging? Are they using them for access to prey, like some other predators might do? And if they are using them for movement, what are the movement patterns along these pipelines compared to other linear features or through undisturbed forest? So we're in the process of analyzing those data right now. So I don't have any conclusions for you on that work, but just to show you some of the stuff that we saw while we were out there this summer, lots of different grizzly bear activities along these pipelines. Everything from digging up ant hills and ant logs, lots of anting on these pipelines, a wasp nest that was excavated and all the wasps were eaten. I had some graphic pictures of bear scat full of wasps, but I don't know, tastefully chose not to include them, but so also some digging of heavy sarin root, sweet vetch root, foraging on, this is alfalfa, and we even found on a pipeline that had, that coincided with power line, I don't know if you can see this hair on here, but we found some power poles being used as rub trees or rub poles. So we'll be reporting on these data in our report, Alberta Upstream report, like some of the rest of you, in March of 2013. So just some acknowledgements. Of course, there are lots of people that contributed to completing this study.